Okay. Yeah, so it took me about 12 minutes to do the whole thing. And my rule is usually, I sometimes say times six. That's more for at level class. I think for honors, it does take a little bit longer for me to process. So I think I should be fine. What I did do is I did take the template from an old AP Calculus test, like old when probably guys were still in diapers, like that old. Um, but then I changed obvious things around. And we used to have our students do it in 60 minutes. So I feel you guys can do this in 60 minutes. There was one question I had to take out and replace with like the tricky limits, but for the most part, I kind of kept a lot of the questions that change numbers around or change equations around, things like that. So you'll when you look at tests look awfully familiar, like it's kind of the same headings. Number one's gonna be the same thing. There's gonna be a true and false question. I told you that. And then you'll see fit limits like these, and then a bunch of other stuff. So should be all very pretty similar. So I've worked it out, but now I'm working through the rubric just to make it neater and figure out the points I want to assign. So here's how I'm doing my rubric. I break this off into three fractions because it's minus and plus, right? So it's 5x sine x over x squared minus 2 over x squared plus 15x squared over x squared. Okay, so that's the first thing. We want to break it off. Then we want to simplify these, right? So you have the limit as x approaches infinity, 5 sine x over x minus the limit as x approaches infinity, 2 over x squared plus the limit as x approaches infinity, 15. And then you just work them out. 0 minus 0 plus 15, 15. So the way I'm going to do the points, this would be worth a point. Then these would probably be worth that probably be worth like a half point, half point, half point, half point, half point, half point, and of course 1 point for just giving the final answer. So you do it 1, 2, 3, 4, 5 points. So that's how I want you to produce the answer in this manner. You don't have to be too long-winded. It's actually very short, very smooth. You can see why I could do this quickly. Oh, let me lower Lynn in. Okay. And then there are questions. Um, Someone's asking what this is the answer 20. No, it's not 20. Because remember when you have I know why you said 20 because you probably did we have 5 sine x over x. You thought it was 5. Remember x is approaching infinity, so that goes towards 0. If x is approaching 0, then I would agree with you. But x approaching infinity, so that's why it's 0 plus 15. And then there are hands raised. Arav, Marie, and I think Simona had a hand raised. That's may not anymore. But Arav, why don't you go first? I'll go Marie after that.
Like two things. Could you explain to me like when it's going to infinity what you plug in for x to make 2 over x squared equal to 0? And then also,
Just
do we
just do.
have to do these separate limit things or can we just put a bracket over all of them and calculate it?
Actually, I could have done that too. You know what? I don't know why I didn't do that actually, because I'm simplifying, obviously. So yeah, that's fine too. Yeah, yeah, and yeah, just let x be large. 2 over large number 0. Don't overthink it.
Oh,
Don't overthink it. Your denominator is large. Go under 0. That's it. And Marie, you have a question.
You answered it. Thank you.
Okay, and Catherine, you have a question.
Yeah, there's like one section on the like notes sheet. It's about limit theorems and it's like limit of as like
Hmm.
x approaches c of like f of x plus g of x of like
Yeah, yeah,
x times g of x and like f of x to the
yeah,
r over s. Like,
yeah,
are we like we've never really used that in
yeah.
class.
Actually, we are. I did it right here. Actually, we have been using it. We use it all the time. It's
Like,
I'm just not like super intentional of like telling you I'm using it, but All it means is if you have two things being added and you're doing a limit of those two things being added, you can do the limits of them separately. That's all it means.
Okay, so like what's the
Although we,
like
we are doing it.
so then what's the like limit f of x to the r over s?
That's just if you have a power root. So if you have the limit of like root whatever, then just take the limit of what's inside the root and then root it afterwards. Like for example, we've actually been using that. Like if you have the limit as like x approaches 4 a root x, great. Just take the limit as x approaches 4 of x and then root it afterwards. I mean, it's easy just to plug it in and just work it out, but that's all it's saying.
Okay.
That's what I'm saying, just common sense. Like you don't have to really think about it too much.
Okay.
It's just telling you to break apart these expressions and do the limits individually. That's all it's telling you, which we've been doing all along. So nothing really to be too concerned about. I mean, or so intentional about it. You're just using your common sense math skills, if that makes sense. Simona, you have a question?
Yeah, I was wondering, this is like a different prop or like a
Yeah,
different
sure, sure. Yeah.
thing. For the like intermediate value theorem
Yeah.
is what it's called. Um, for that, I don't know like how I would know what numbers to like try to plug in.
Sure.
I'm kind of confused on that.
Okay. So let's see right here. It says it's crossed out, but obviously we are doing it. So yeah, let's walk through walk you guys through this process. But Kaden, you had a question also. Do you have a question about the previous question or something new?
No, it's a new question.
What's the new one?
It's a yeah, it's a new question.
But what is it? What is it about?
It's about when you say support an answer using the definition of a limit, like what does that mean?
Um, well, what do you mean by support?
Like on question 7D, it says, does limit of as x approaches 1 of g of x exist?
yeah,
And
yeah.
then it
So you
says
have to
support your answer by
yeah,
using the
I
definition. Is it
yeah,
just
yeah,
left-hand limit
correct.
equals right-hand
Yeah,
limit?
yeah,
Okay,
yeah,
cool.
yeah. That's it. Yeah, good question. All right, so let's take care of the IVT now. So here's how I get started. Uh, so show clearly must equal 0. Okay, between 1 and 2. Okay. Well, let's find f of 1. See what happens. You get 1 plus 1 minus 3, or 1 plus 4. So that's negative 1/5. Okay. Let's find f of 2. That's 8 plus 2 minus 3, or 2 plus 4. Okay, I got a negative and a positive. Now, of course, they kind of told me what to look at, but let's say that you weren't told that at all. So you had to come with your own interval. I mean, just choose small numbers. So, like, always start with 0. See what happens. If it's positive, cool. Now let's find something that's negative. And if you can put in like 2 or 3. I mean, you'll find something. It's not gonna be that hard. Um, or maybe pulling a negative number. Like you'll be fine. That shouldn't be too concerning. But no to do that, obviously. So you have a negative and a positive clearly, right? So zeros right in between that. So then once you do that, then you can start making your statement. You can, I'll type it up. You could say, hmm, f of x is continuous for all real numbers. So f of x is continuous on the interval 1 to 2. Since f of 1 equals negative 1/5 and f of 2 equals 7/6, then due to the IVT, there must exist at least one x value in the interval where f of x equals 0. Let me resize this, clean it up a little bit.
Wait, Mr. E, how do we know that f of x is continuous for all real numbers?
Actually, for this one, you're right. Never mind. It's not. Well, it is continuous for f of, actually, you know what? That's why I think we had a specific limit because it's not continuous to -4, obviously. So, then in this case, I think I said too much. But for polynomials, yes, you could say that or anything else like exponential, whatever.
Would you have to say that like it's continuous because it's a polynomial function, or will you just say that it's
No,
continuous on the
just
variable?
say it's continuous. Just say it's continuous.
Will
Yeah.
you be giving us an interval as well?
No, I will. It'll be more like the homework, where, but you know, it'll be continuous for all real numbers, and then once you determine what two values you want to use, you say, well, since f of x is continuous for all real numbers, then f of x is also continuous for this interval, and then you'd say, hey, f of 1 is this, f of 2 is this. Then due to the IVT, there must exist at least one x value in the interval where f of x equals 0. That's
And
it.
like, if we don't have an interval, is guess and check the best way to get our positive negative interval? Is there
Yeah, but
some sort of
yeah, but you're not gonna have to guess the check. It's gonna be really easy. Like, I mean, again, like plug in 0 will be super easy, and it'll be very obvious. Like it's not gonna be that confusing.
okay.
Oh, but what I do need to see, excuse me, tired. So this would be worth like a point. Um, trying to think here. I think this would probably be worth this whole situation would be worth a point. Saying this would be worth a point. Um, and I think like there as at least one x value, blah blah blah, and then where f(x) equals 0. So there's your 5 points. 5 point question. So it's not much to show, by the way. Just do the little mental math with the numbers and make your statement. You move on. It's really really straightforward. There's no tricks. I could have made this very tricky. I did not do that. I'll make it tricky for the final exam or our next test. Should be very straightforward. Okay. Hopefully we can close that loop. What else we got?
Could we do a squeeze theorem one?
Sure. I know it's funny because I don't know. Yeah, I think I may have asked it in a more recent year. I think the college boards were more intentional about asking that. Actually, I do see one. Okay. This is the 2025. Here we go. Okay. Okay, here, squeeze term. So, and there's some chats. Yeah, I could do D of limits. So Sophie, you want me to do D of limits on the
Yeah,
old
like
exam?
the
Okay.
previous.
Where we were yeah, yeah, we'll go back. We'll go back. No
Okay.
problem. Oh, Lucas, you're very welcome. It's very kind of you. Um, okay. So now, yeah, what would I do here? I'd say let f of x equal x squared times sine 1 over x. And by the way, I'll do my best to make this video accessible by late tonight, probably around 10:30-ish or so. Hopefully, it should be ready. So I'd say that. Also, g of x equals negative x squared, and h of x equals x squared. Um, then I would make this statement. Since g of x is less than or equal to f of x, is less than or equal to h of x, and technically should say for all of x, but if you don't say that part, that's okay. But technically you should for all of x. And the limit as x approaches 0, the g of x equals the limit as x approaches 0 of h of x, which obviously both equal 0. Then due to squeeze theorem, the limit as x approaches 0 of f of x equals 0. So the way I would divvy up the points, probably 1 point for that, assumption, then 1 point for this statement here, and then another point for this statement, another point for saying squeeze theorem, and another point for that. So there's your 5 points. That's what I'm looking for.
How do you determine to use negative x squared and x squared? Do you just use a part of the expression that has
But that doesn't have the trig and make it negative and positive. Yep, that's it. Because sine is only one that fluctuates between -1 and 1. So sure. What's the lowest sine could hold? It's -1. So negative x squared is the lowest we can go. What's the highest sine could be? +1. So x squared is the highest we can go. That's your range. So what trying to do, you're trying to find a range of expressions, not of numbers necessarily, but to help you think numerically, think about the range of sine between -1 and 1. So multiply x squared by -1, multiply x squared by 1. So the function that we're talking about is between negative x squared and positive x squared. Someone go ahead.
So for like basically what you're supposed to do is find the range for
Mm-hmm.
sine or like
Yeah.
whatever function you
Yeah.
have, then multiply it by the other part.
Yeah.
Or okay.
Yeah.
Okay,
Yeah.
great.
Yeah. Very good.
My question's not about this question, so I don't know if
Okay.
anyone.
Well, so what's your question? You'll be next in the queue, but I'm gonna take care of Sophie's question.
Okay,
But
mine's
what's
about
yours gonna be?
it's about page. It's like when you have to find the value of a constant, and it's like given that the function, and then it's like a piecewise is
Oh
continuous.
yeah,
So
yeah, yeah. So, let's talk about that. Yeah, yeah, yeah. Let's say that after I finish this. Actually, there's one right here, I think. Yeah, well, let's do that. Ooh, that's a good one. That's a really good one. All right, yeah, let's do that one on page 6, 7. There we go. All right, okay. Um, this is what date? This is 2017 exam. I'll do that one after I take care of Sophie's question. I like that one a lot. Okay, so Sophie, you're asking about D here, right?
Yeah.
Okay. So first thing I'll do is this. Then might as well factor out the X from that expression. And down below, I'll clean it up. But I'm also going to say the limit. Okay. Then that's negative X. The things should cross out very nicely. So the limit. Yeah, 7x cubed. 5 plus root 25 plus x over -1. Plug in 0 for x times 10. You should get -70. Yep. So the way I would divide the points, that would be worth a point, showing me that process. And then kind of going through the motions, another point here, another point here, another point here, no point for the final answer. That's it.
On the answer key, it says 20.
I may have made a mistake. Hold on. Oh yeah, that's because I can't do math. That is correct. Yes, it is 20. You're correct. Thanks. Okay, Lucas, you have a question.
Oh, I was wondering if we could go over 3B because I think I know how to do it, but I want to make sure like I'm doing it right.
3B, okay. But hold on, let me get to Marie's question because she's next.
Okay.
Okay. I mean this one here, 3B?
Yeah.
Oh, let me do it really fast. Okay. I'll get to Marie's question after that. Okay, and you're welcome, Sophie. And then Anna's got a question. Yes, I'll after I do Marie's question, I'll do Anna's question next. That's a really cool. You guys have some cool logos. Like boring. All right. Let's see here. Yeah, so well, B root f of B, right? Just substitute. And if you think about it, you already know the limit is x approaches b of f of x is 25, right? So this kind of implies that f of b does equal 25. So b times root 25 is 5b. Or you can use limit properties. The limit as x approaches b of x times the limit as x approaches b of root f of x. So that's going to be b, and then that's just going to be the root of that limit. That's using the limit properties, which you know is 25. So you get 5b. Okay, let me take care of 8 here on the 2017 exam to answer your question, Marie. That's a good one to do. I like that one a lot. And then we'll take care of Anna's questions. Yeah, that's a good one. Okay, so we have the force issue of continuity. So first off, f negative 2 equals q, so check. Then the limit as x approaches negative 2 of f of x. We have to investigate that. So I'm going to do left and right hand limits. That's going to be the left side, I have to do x squared plus 4p squared. So that's going to be 4 plus 4p squared, because you're squaring negative 2, of course. And this one's going to be negative 4p plus 3. So in order for this to exist, 4 plus 4p squared must equal negative 4p plus 3.
So
Move
you
things
just
around.
split it up into the left-hand limit and the right-hand
Correct.
limit, and then since
Correct.
it has to exist, you set them equal.
Correct.
Okay,
Yeah,
thank
because
you.
you're forcing the issue, right? And they get 2p plus 1 squared equals 0. P equals negative half. Then lastly, f of negative 2 has to equal the limits. Well, f of negative 2 is q. And the limit, you could use either expression. It's up to you, whichever one you want to use, because they're both the same, which will be 5. So basically, check, check, check.
Do we have
You're
one
good.
of those on the test?
You can. I just said something about continuity. Yeah,
Oh
you
yeah, okay.
could. Yeah, you could.
Wait, Mr. E, how did we get Q is equal to that? Like, how is Q equal to one of
Okay.
those equations?
Let me separate it out because the colors are blamed too much. That's your first condition. So f of -2 is Q. You said so, right? That's your second condition, where I forced the issue of continuity. I mean, I forced the issue of the limits, right? I did left right hand limit 7 equal to each other, solve for P. And this is my third condition, where f of -2 has to equal the limit. Well, I know what the limit is. If I know what P is, the limit's 5. So f of -2 has to equal 5. And what does f of -2 equal? Q. So I make that substitution, Q equals 5. Because remember, I'm going through the entire continuity definition. Conditions 1, 2, 3. Condition 1, condition 2, condition 3.
Got it. Thank you.
Condition 3 is telling me f of -2 equals limit. Now I know what P is. I know what the limit is. It's or go over here. I don't care. It's 5. So that equals 5, and then replace f of -2 with Q, and you get your answer. Ken, let me get to your questions now. Let's see. What was your question again? Luke's, yeah, go ahead. 5 DEF 2024. Okay.
Is there gonna be any, are there gonna be any questions on like graphing polynomial functions and like with
No, no, no,
everything?
no. Yeah, you guys know what's going on with it. We've done enough work. I think it's fine. I don't think we need to do that. Like it was with rational functions. Hold on. That's 2025, so 2024. It's still 2025. Okay, let's go back. Okay. Let's do this. And then, so if I know you have your hand raised, just hold on a sec. So if you approach 2 from the left side, you have to go with this one. So yeah, cosine 2 pi over 2. Oh, that was a doozy. 2 minus 2 minus. Well, it's one up top, and you could just sort of guesstimate like it's like 0.001. So basically that's positive infinity. And then for E, 2 from the right, then you gotta go with this last expression. And you can totally do that, by the way. It's totally fine. Um, I mean, it does say analytically. I mean, doing a sign chart for this, I think would be a kind of a pain in the ass. I think I would just have you state it for this question like this one. Because we will have a piecewise. Did say that. Um, but I want to make you do a sign chart because that's just totally crazy. Now here, yeah. So I got to plug into the second one, and when you are plugging in, I mean that is an algebraic process, so it is analytical. Okay, later in the evening, my handwriting gets worse. So let me redo this. Yeah, that's just actually pretty straightforward. That's -80 plus 4 over 2, -38. Yeah, because you got to go with the bottom one because x is bigger than 2. And of course, that's D and E for the last one. And that's because the left hand limit is not equal to the right hand limit.
how come you could just plug in 2 instead of 2 plus into part E, where versus in part D you plugged in 2 minus?
Well, the reason why I did that is because I got zero on the bottom, so I had to make more sense of it. But here I plug in always just plug in the number, see what happens. Because if it comes out super clean, then there's you're done, right? And of course I'm going with the bottom one for part E because X is bigger than 2, right? I wouldn't go with
Yeah.
any other expression. I have to go with that one. I have no choice. And it just came out, it was just plug and play, like plug it in. Cool. There you go, done. Now for D, yeah, I plugged it in. I had an issue. I had zero. So I had to get more granular. As I got more granular, like, okay, 2 minus, fine. That's like 1.999. Cool. I have 1 over 0.001. Cool. I got positive infinity. I could have done that for E, but it's a lot. Why? It's just plug it in for E. For D, that was an issue. I had a zero on the bottom, so I had to investigate a little bit deeper. Does that make sense?
Yeah, thank you.
Okay, cool. Okay, Sophie had a question. You had your hand raised earlier.
Yeah, I was wondering if you could do like a
Hmm?
problem where you have to draw the graph based on
Yeah,
like the
I'm
limits.
surprised no one's asked that yet. Okay, let's see that now.
I think there's like two problems in the homework that was like that, but
Yeah, let's do one here. Let's do the 2017 exam. Here we go. Okay.
Mm.
So usually what I'll try to do is I'll try to focus on any limits or things that involve one particular X value. Like obviously I see this happening. This tells me I'm going to have a hole because the limit exists, but F1's something else. F1's -3, but limit's 1. So will the graph look like this? I don't know yet. I'm not sure, but at least I know that's happening there. If I do go to the left, it's got to go up forever and have nothing else. I'm sorry. Oh my gosh, this is how tired I am. Wow, I can't believe I did that. F of 1 is -3. Okay, I didn't go crazy, guys. My apologies. All right. Sorry for any confusion there. I'm glad no one's like freaked out. Okay. And right, there's nothing else going on to the left of 1. No, there is. There's -4. Okay, so but it could look like this. I don't know. Now here, that's a jump. Because what's happening here is you have your left hand limit, right hand limit are two different numbers. So I approach -4 from the left, I have 3. From the right, it's going to be -2. So yeah, I mean, I could do this, I suppose. I could put a hole here and make that included up here. Then this means it has to point up forever. I could do that. That's possible. So I'm building this. And then here, as approach 3 from the right, that's a vertical asymptote or infinite discontinuity, if you want to call it that. So you're definitely have this, and it's going up. So it's like this. And then this is going to be 2. Now I'm only supposed to have one x-intercept. So I don't want to do that. So I create another x-intercept. So what I'll do that. And that's been taken care of. And my domain is 3 is excluded. Okay, good. I've made it as continuous as possible. I'm not displaying obviously the vertical line test. Yeah, there you go. There's my graph. So Simona, go ahead.
I have two questions. One, um, like when you filled in one of the circles, did you need to do that, or could they have both been unfilled in?
Here,
Yeah.
that'd be a problem. You wouldn't get the answer for the first bullet point.
Oh, okay.
Right? And now whether I did this one, like I put a hole here and filled it out, that doesn't matter.
Okay.
Because there is you know, multiple possibilities. I mean, if you really want to get kind of funky, I don't care. You want to do that if you want, go ahead.
Okay, and then my second question is that you can just like randomly draw in horizontal asymptotes like
Yeah.
whenever.
Yeah.
Okay. Okay.
Yeah. Yeah. It's, they don't have to be the same for both sides. So, or you can have one on one side with none on the other side. So, Laura, you have questions? Go ahead.
I was wondering if you could explain like the composite limits, especially like the
Yeah.
ones at the end
Tricky.
of the homework.
Yeah. Yeah. Let's do some on the test from last year. And then, Maria had a question.
Yeah, mine's about when you have an absolute value in one and you're writing it as a
Yeah. What's that?
piecewise.
Yeah. Let's actually take care of that really quick, and then we'll do the tricky limits after that. The- Piecewise. I know exactly what you're talking
I
about.
was doing number 3 on the
2017.
I was doing it on the 2024.
Hold on. 2024. Yeah, I mean, if you're doing it analytically, yeah. I was thinking of like we have something like this, which hopefully you guys could recognize as this. Hopefully you guys are cool with that. Like that's one thing. But then you got to take it further, make it a piecewise. And I know that's what you're asking.
Yeah.
So here we go. Negative x squared, 4 minus x. And then you have this. Now, the way I would think about this is that if you graph that 4 minus x, I mean, it's obviously going to cross x at 4. It's got to stay positive the whole time. Does have a negative out in front. So I know it looks like that. So now, what if x is less than 4? That's a negative. I'm focused on this part. That's a negative slope. Crossing the y-axis at 4. So that's going to go with this one. What if I look at the right side? Positive slope. Well, so it's going to be -4. It's got to be this side. And we can't include 4 because that would be undefined, so I'm not going to include it. And then you just clean it up. Now these will cancel, but you got to leave behind -1 because you can factor out negative from 4 minus x and make it this. So it becomes positive x squared over 6. Then here, those go away. It becomes negative x squared over 6. X less than 4, x greater than 4. So if I'm approaching 4 from the right side, I better use this one. So it's negative 16 over 6, which is negative 8/3. Okay.
Thank you.
Wait, so for that one, would we need to
Of
show like the whole function and then the
Yes.
last part? Oh, okay.
Yes. Yeah. Because you got to clean up. Yeah. You got to tell me how you got there. Yeah. That's a good one. I like that one a lot. Yeah, that's a really good one. Okay. Let's do tricky limits. Yeah, you guys have been asking fantastic. This is probably one of the best Zoom session I've had for a class. I mean, like some people are like, oh, just do stuff, like, well, what do you want to do? Like, you guys are good. Or maybe I just provided you with good problems. It's all me. Just kidding. Um,
Can you do number 6 of the tricky limits one?
sure,
I
sure,
think it's on
sure.
the next page.
Wait, hold on. Let me do it from the Well, let me talk about these here because I know Laura was asking me, and I could do some more after this. So yeah, let's look at part A, right? Like, okay, x approaching 3 of f of g of x, and you have the graphs here. Well, if I'm approaching 3 for g of x, I know it's 0. Um, and I'm approaching 0 here, I know I get 1. So that's a pretty easy one, right? That's not so hard. And remember, this will change, right? Based upon this. That's what's happening. Now where it gets a little dicey is the next one, g of f of x. The x approaching 1 for f of x, of course it's 2. But if I'm approaching 2 here, I want to say it's d and e. But it's not d and e. Because what's happening is that when I take the limit as x approaches 1 of f of x, is it really 2? Or is it 2 minus? Because what's y getting closer and closer? It's getting closer to 2, but 2 from below 2. Like 1.9, 1.99, 1.999, and so forth. So then I take the limit as x approaches 2 from the left side of g of x, which of course is going to be 2. And that's my answer. I get 2. So hopefully that helps to understand the mindset for going over the tricky limits. And then there's some more here that we could talk about. Sophia, you said that there's some good ones. Which one do you want to look at?
Like number 6, it's like the very last part of the packet.
Okay, hold on. To answer your question, Emma, no, we don't have to grab polynomials. The trig identity, yeah, as sine kx over x is x approaches 0, that's gonna be k. That's correct. And of course, it's approaching infinity, be 0. I have a question on a test. There are 10 questions, but the first couple are pretty short. Well, one's not even really a question, it's just do you write the limit notation correctly all around the test, and those true and false. So yeah, I'd say it's more like 8 questions. I mean,
So is
no,
it almost exactly the format of the first like
yeah,
practice one? Oh, okay.
correct, yeah. Okay, so hold on. Wait, which one, Sophia?
It's further down.
Yeah, okay, yeah,
Next
sorry.
packet. Yeah,
Here we
number
go.
6 of that.
Oh, yeah, all right. Now we're talking. Okay. Um, so remember, it's a transformation. If we go one down, it's a graph that look like this. And of course, if I'm approaching 2, I don't know. I mean, looks like D and E, right? Um, and of course, there's a -6 happening afterwards. So what I'll want to do is, and there's no other function going on here, right? No, okay. So what I want to do is I want to treat it like a left-hand limit, right-hand limits. So because yeah, fine. I mean, you can see we can't really use the limit properties here because like that's what you're trying to do. You're trying to do limit all these things individually, like fx minus 1 squared, -6. But because the limit of fx minus 1 squared as x approaches 2 is d and e, I can't use the limit property. So what I'm going to do is I'm going to do my left-hand limit, the limit as x approaches 2 from the left side. And if I approach 2 from the left side, f of x is going to be or f of x minus 1 as that entity is -2 squared -6, which is 4 minus 6 or -2. Then if I do my right-hand limit, well, as x approaches 2 from the right side, well, if I approach 2 from the right side, it's still 2. Yeah, this entire entity, because I've already done the transformation now, so I don't have to do anything with the -1 anymore. I've already shifted it 1 down. Which is still 4 minus 6, which is -2. So that's why it's -2. So what you do is you got to take that fx graph, perform the transformation to it, and see what's going on. But then the limit as x approaches 2 of the transformed graph is still D and E. So if I treat it as the left and right hand limit, oh, if I approach 2 from the left side, I got this. 2 from the right side, I got this. Oh, okay. Both right hand limits are the same. Then that's your answer.
Okay, thank you.
Yeah.
Will they be this like complex on the test?
Not quite that.
Okay.
But again, these are great opportunities for me to retest these later on. I would say it's more like what I just did earlier.
Okay. Sounds good.
So we'll be able to use the limit properties to solve these kinds of problems. We don't have to do.
Well, no, if the limit product doesn't work, then you have to um
Yeah, but for our
you have
test,
to
you're
write
not gonna
down.
be. Will you still? Can you ask us questions like that on the test, or are you gonna keep
Like
it simpler?
6? No, I
Like
said not.
say,
No, I said I'm not going to. I just said that. Like
yeah. So
written
we'll
it
be able to
down.
use on our test. Will all the problems like this be able to be solved through the limit properties? I guess that's my question.
I mean, I have to look. I can't remember what the other question. Actually, I have it right in front of me here. Um, Switching here. Um, yeah, for the most part, yeah. I mean, it's yeah, you'll be fine. Yeah, yeah. I do have to go in a couple minutes, guys. So um, I do have to sign off. But um, just any burning questions. I mean, but we've pretty much covered, I think, a good. I mean, I'm looking at the test right now, and I don't think we left any stone unturned here. But Catherine, you have a question?
Yeah, I was wondering if you could just remind me really quickly, like, for the limit as x approaches infinity of sine x over x, what is that?
Yeah.
0, and it's the same for sine kx over kx.
Yeah,
Okay.
because the bottom's getting bigger. Yeah, that's what's happening. Okay, and I'll do one more question. Somebody have a question?
Yeah, I was wondering, like when you did the these like composite limits like earlier on, like when they were 0, why didn't you like do like 0 plus or 0 minus?
For which one?
Like it was one of the previous ones we did. It was there was like the two of them and one of
Oh,
them,
hold on. Let's see here. You mean like right here?
yeah. For the first one, why didn't you? Because like
Well, I didn't need to because it was just so obvious as one. I didn't feel like it. I didn't bother to do that because it was a simple one. I mean,
okay.
I could have as X approaches 3. Actually, I couldn't because X approaches 3. It's coming from both sides, so I didn't have that luxury. I didn't have that option anyway.
So so when it's that, then what do you just like leave? You don't do plus or minus, you just
No,
leave.
you can't.
But then how do you solve the problem?
Well, because fortunately, it was 0, and 0 is just right there, 1. But if there was something, if there was a discontinuity
Okay.
at 0, then I would be D and E.
Okay, sounds good.
Yeah. So, yeah. Anyhow, okay, Sydney, I'm sorry, you had a question. What's your question?
Just really quickly, when you did the squeeze theorem, you kind of wrote out like an entire thing. Can we
Yeah.
just write it mathematically, and then would that be like enough?
What do you mean by mathematically?
Like, could I just write, oh, for the squeeze theorem, like if I just write like, oh, limit as x approaches 0, it's 0, like x squared sine 1 over x is between
Hmm.
0 and 0, then it equals 0. Is that enough? Is that sufficient?
Um, Wait, repeat that one more time.
If I were to write like limit as x approaches 0, x squared equals 0, and then 0 is less than or equal to x squared sine x, is
Yeah, that's fine. That's fine.
that's fine. Okay.
Yeah. All right, I'm gonna sign off, guys. All right. Well, you guys have a good night.